In this video, we are focusing on scientific notation. When working with very large or very small numbers, we can write them more efficiently using powers of 10 with positive and negative indices, also known as powers. So if we have a positive power or positive indices of 10 and we have to multiply, we will actually end up jumping to the right-hand side. If we are multiplying with a negative indice or power, when we multiply, we have to jump to the left. Let's take a look at this first couple of questions that we have here. So it says express in decimal form and written in basic numeral. So I go 4.5 multiplied by 10 to the power of 6. So the easiest thing to do is to rewrite this 4.5 with some zeros on the end because it's a positive power and I must jump to the right. So I'm going to write down the bottom here, 4.5, and I'm going to use this power and write 6 zeros. It's a good indication to start there with the power on how many zeros you can put in. So now I'm going to multiply this. And I start here with the decimal point, and I have to jump to the right-hand side 6 times over 6 numbers. So here we go. 1, 2, 3, 4, 5, 6. And my new decimal place sits there. So underneath that, I can actually write the answer. I'm a bit squashed in the bottom here. So 4, now this decimal has gone, so now I write the remaining numbers until I get to this decimal point here, because that's the new one. 5, 0, 0, 0, 0, 0. So 1, 2, 3, 4, 5, 6, 7 numbers. 1, 2, 3, 4, 5, 6, 7. So my answer is 4,500,000. So just going back through this one again, it's a positive power. Positive powers multiply and we jump to the right from the decimal point. So I rewrote the number here, start on the decimal point, and I jumped 6 times, made a new one, and rewrote the answer. I'm going to do the same thing over here with this one. This one's actually a negative. So when we write negative answers, because we're going to jump to the left, I'm going to put the zeros in front of the number. So I'm going to write 2.3 over here. I'm going to take it how many powers we have here. So the indice is negative 3. So I'm going to put some 3 zeros in front. So 1, 2, 3. And then I'm going to multiply that by negative 3. So I'm going to jump to the left 3 times, starting from the decimal point. 1, 2, 3. And then I rewrite my new decimal there. Now what I do is rewrite the answer. So equals 0.12, so 2 zeros, and I write 2, 3. So this number here, even though it's sitting on the right-hand side of the original decimal, it's still included. All I've done is move the decimal negatively to the left 3 times, as it told me to, and I have a new decimal place, and I rewrite the answer. So 0.0023. We're now going to change things up a bit. Before we took the scientific notation and changed it to a basic numeral. Now we're going to take the basic numeral and change it into scientific notation, as the question says here, written in basic numeral and expressed in scientific notation. So we're going to look at 4 questions here. We have 2 whole numbers and 2 decimals, and 1 is a negative. And I'm going to start with the first one here, and it's 9,700. Now, what we have to imagine here is that we have an invisible decimal already at the end of this whole number. When doing scientific notation, we have to look for digits that are not zeros. So I could see a 9 and a 7 here. We take the pen and place a decimal point after the first digit and in between the second digit of 7. It doesn't matter what comes after the 9, we simply put a decimal after the first digit that is not a 0. And then we take the digits that aren't zeros and write them down below. So we have 9.7. We go multiplied by 10, and now we have to figure out if it's a positive or negative power. It's positive because we're going to have to jump to the right to get to the invisible decimal place. So how many jumps we take will determine the power we give it. 1, 2, 3. It is a positive power of 3, so we have 9.7 multiplied by 10 to the power of 3. In the second question, we follow the same process and we look for the digits that are not zeros. After the first digit, which is the 8, we place a decimal point, and then we take all of those 3 numbers and rewrite them below. So we don't just have the 8 or the 8.3. Everything that is not a 0 gets written down. Then we go multiplied by 10. Now, we have to jump to the left to get back to the original decimal place, which means it's going to be a negative power. How many jumps will determine the negative power? 1, 2, 3, 4. It's a negative 4 power because we took 4 jumps to the left. So we have an answer of 8.32 multiplied by 10 to the power of negative 4. In this next question, it's very much the same as the first one. We find the digit that's not a 0 and we place a decimal point after it, and in this case we just have a number 7. So we write down the 7 multiplied by 10 because we're setting it up, and now we think, okay, how many jumps do I have to take to the right to get to my invisible decimal place? 1, 2, 3. So it's a positive power of 3. So that is 7 multiplied by 10 to the power of 3. And last but not least, we have a negative decimal on the far right. Ignore the negative symbol and deal with it at the end. So again, we're looking for a digit that's not a 0, and the only digit I can see is a 4, so it gets the decimal place after it. I then write down the 4 multiplied by 10, and I ask myself, what do I have to do to get back to the original decimal point? And that means I'm going to have to jump to the left, which is a negative power, and I must take 2 jumps. 1, 2. So my power is going to be negative 2, and because it's a negative decimal, the 4 will take on the negative. So I have negative 4 multiplied by 10 to the power of negative 2. So basically, when you look at these questions, when you get the big whole numbers, you've got to jump to the right-hand side to get back to the invisible decimal point, and that gives you a positive power. When dealing with decimals, you're going to end up having a negative power because you're going to have to jump left back to the original decimal point, and that's why you have a negative power.